Hello students, welcome to Learner's Planet, problem solving session 4 of chemical reactions and equations. In our previous sessions, we discussed questions about balancing of chemical reactions and also the types of chemical reactions. In this session also, I'll be discussing few more reactions about balancing. Okay. Now let's take up our first question, which is balance the given chemical equation. Now what is the chemical equation, students? It is H2S, that is hydrogen sulfide, is reacting with oxygen forming SO2, that is sulfur dioxide, and water. Right? Now how do we balance? Do you remember how do we balance? We just count the number of atoms on LHS and RHS. Okay? Now let's start doing this. I hope till now you are able to balance the equations. Right? Now what I am seeing here is, children, this is H2S, H2O. How many hydrogen are here this side, children? It is 2. This side it is 2. That means your hydrogen is balanced. Okay? Now let's check out for sulfur. Sulfur on LHS is 1. On RHS is also 1. So this is also balanced. Okay? Let's check for oxygen. It is 2 children here, and on this side it is 2 plus 1, 3, right? So what we have to do is, we have to change the number of oxygen atoms to even, right? So what can I write here is, what coefficient I can put in front of oxygen? That is, let's start with H2S plus what I can put here. If I am putting it 3, thrice of O2, what I will get, children? Now this side, so how many oxygens are present this side on the LHS? SO2 plus of H2O. Now check out how many oxygens are there here? 6. And this side it is SO2 2 plus 1 3. Now what can be done is, if I can make this 2, what will happen? Let's write another equation with the coefficient in front of SO2. Okay, children, so it would be H2S plus 3O2. This is not 30, okay? 3O2 is giving you what? It is giving you how many, this thing, I am saying I am making it 2SO2, right? And if I make this 2H2O also, then is the number of oxygens balanced? This is 2 oxygen this side and 4 oxygen this side, right? So how many oxygen are there, children, in RHS? It is 6, and in your LHS is also 6, right? Now what is unbalanced is, check for the sulfur. How many sulfur are there? 2. This side it's 1, right? How many hydrogen are here? 4. This side it's 2. So what can I do is, I can put 2 in front of H2S. So if I am writing it 2H2S plus 3O2, and what is it giving, children? It is giving you 2SO2 plus 2H2O. Now is the equation balanced? Let's write LHS and this is RHS. Right, children? Now on the LHS, How many hydrogen atoms are there? 4, right? How many hydrogen atoms on RHS? It's 2. It's 4, sorry. So, the number of hydrogen atoms on RHS, children, it is also 4. Clear? So, what can I write here is, I can write here 4. Right? Now children, what about sulfur? How many sulfur are there on the LHS side? It's 2. And on the RHS side is also 2. So I'll write here 2 and 2. Clear? What about oxygen, children? How many oxygen are there on the LHS side? It's 6. And on the RHS side, just count. I'll write it here 6. Let's count it on the RHS side. It is 2 2s are 4. 4 plus 2 is 6. Clear? So, how many is oxygen on the RHS side? It is also 6. Now, is our equation balanced, children? Yes, our equation is balanced. Right? This is the way we are balancing the equations. Now, let's take up our next question, children, which is again a balancing question. Balance the chemical equation. Right? What all are the reactants here, students? It is aluminium. What is Fe2O3? What do you mean by Fe2O3? Fe2O3 is iron oxide or ferric oxide. It is giving you what? Aluminium oxide and iron. Right? Now let's start balancing this equation. Right? Now children, how many aluminium are there on the RHS side? It's 2. On the LHS it's 1. So what can I make here is, if I am writing it as 2Al plus of Fe2O3, and it is giving me what, children? What is the product it is forming? It is forming Al2O3. That is, your aluminium is balanced, right? So I'll write here Al2O3 plus of Fe. Just check out, children, how many iron are there on the LHS? 2. So on the RHS, how many iron should be there? It should be 2. Now, is our equation balanced? Yes. 2 aluminium, 2 aluminium. 2 iron, 2 iron. 3 oxygen, 3 oxygen. Am I clear? Right. So, this was again a balancing question. Right? Now, let's take up our next question, children. That is, balance the chemical equation. It is Na plus H2O gives NaOH plus hydrogen. Right? How we will balance? What is the thing which is unbalanced in it? What is it? Here there are 2 hydrogen on the LHS. How many hydrogen are there on the RHS? It is 3. Right? So what can I make this 3? I can make it 4. Okay? So if I am just putting a coefficient like this, Na plus H2O gives what? It is giving NaOH. Right, children? So I am putting here 2 NaOH plus of H2. Clear? Now, how many hydrogen are here now? 2 plus 2 is 4. Okay. How many oxygen are here? There are 2 oxygen atoms. Right? And on the LHS side, how many oxygen are there? There is only 1 oxygen atom. How can I balance this, children? If I'm making 2Na, it means my Na is balanced. Okay, 2H2O. Okay, now what is to be put this side is, now is our equation balanced, children? 2NaOH plus of H2. Is our equation balanced? Check out. 2Na, 2Na, 4 hydrogen, 2 hydrogen of NaOH and 2 of H2. Okay, 2 oxygen and 2 oxygen. So now our equation is balanced. Okay. Now let's take up our another next question. Yeah, this is again a balancing question. Balance the chemical equation. BaCl2. What is BaCl2, students? Ba stands for barium, Cl2 stands for chloride. So it is what? Barium chloride. This is what, children? Aluminium sulfate. Al stands for aluminium, SO4 2- stands for sulfate. AlCl3, that is aluminium chloride. Okay, and BaSO4, what is it, students? It is barium sulfate, right? Now let's start balancing it. From where we are going to start? Just check out for sulfate this side. It is 3 here on the LHS side. How many sulfate are there on the RHS, children? It is only 1. So what can we do first is, I can write this equation as BaCl2 aqueous plus Al2SO4 whole thrice aqueous, and it is giving me what, children? It is giving me AlCl3, right? So AlCl3 plus sulfate is 3 here, so I'll put 3 BaSO4, right? Now, how many sulfates are there on RHS? 3. On LHS? 3. So it's balanced, right? How many aluminium is there on LHS? 2. What about RHS? It's 1. So what I can do is, I can put 2 that side. So our next would be BaCl2 aqueous plus Al2SO4 whole thrice aqueous, and it will give you what? What I can write here is 2AlCl3 plus 3 BaSO4. Am I clear? Now in this case, students, what is left which is unbalanced? What is unbalanced is 2 aluminium LHS, 2 aluminium RHS, 3 sulfate LHS, 3 sulfate RHS, chlorine. There is 6 chlorine on the RHS side, right? What about this side? There is only 2. There are 3 barium on RHS side. What about barium on LHS? There is only 1. So what can I do here is, children? I can make it 3 BaCl2, right? Aqueous plus Al2SO4 whole thrice aqueous, and it's going to give you what? It is going to give us 2 AlCl3 plus 3 BaSO4. Okay. Now 3BaCl2 plus Al2SO4 whole thrice gives 2AlCl3 plus 3BaSO4. Right? Now 3 barium on the LHS side, 3 barium on the RHS side, 6 chlorine on the LHS side, 6 chlorine on the RHS side, 2 aluminium on LHS, 2 aluminium on RHS, 3 sulfate on LHS, 3 sulfate on RHS. Right? So our equation is now balanced. Right, children? Now moving to the next question. Again it's a balancing equation. Complete and balance the following equations. Right? Equation, sorry. It should be equation. Right. Now what we have here is copper. Cu is the symbol for copper, which is solid, reacting with AgNO3. What is AgNO3? It is silver nitrate. Okay. So what will be the products form, children? What should be the products form? Copper is more reactive than silver. I'll make a note here. Right? Copper is more reactive than silver. Right? So what will copper do? Copper will displace silver from silver nitrate. Okay? So what will be the products formed? I'll write the equation here, that is Cu plus AgNO3, and it will give you what, children? It is giving us CuNO3 twice plus silver, right? And that is the solid. Okay, children. Now what all are the things here? On the LHS side, NO3 is 1, whereas on the RHS side, NO3 is 2. So how we are going to balance this? What I can do is I can put 2, that is the coefficient 2, in front of AgNO3. So what I'll get is 2AgNO3, and it gives, what it gives here is CuNO3 twice plus 2 silver. Clear? So is our equation balanced now? It is balanced. So this is the way we balance our equations. Every time what we have to do, children, it is we have to count the number of atoms of elements on the LHS and the RHS. Right? Now moving to our next question, it is again a balancing one. Balance the chemical equation. It is what? P4, that is phosphorus, and it is in solid state, Cl2 in gaseous state, and it is giving you TCl5, that is again in a solid state. Right? How can we balance this? Let's start with phosphorus. Phosphorus on LHS is 4. Right? On RHS it should be again 4. What I'll do here is I can write it P4 solid plus Cl2 gas, and it is giving me what, children? It is giving me 4PCl5 solid. Clear? Now check out for phosphorus again. It's 4 on LHS, 4 on RHS. Now what about chlorine? Chlorine is 2 here and it is 4 multiplied by 5, that is 20. Now how can I make 20 chlorine on LHS? By putting a coefficient 10 here, right? So what I can do is P4 solid plus 10Cl2 gas, right? And it will give me what it will give me? 4PCl5 solid. Now just check out, is the equation balanced? 4 phosphorus on LHS, 4 phosphorus on RHS, 20 chlorine on LHS and 20 chlorine on RHS. So children, now our equation is balanced, right? Now let's take up our next question. It is a different question. What it says, oil and fat containing food items are flushed with dash to prevent rancidity. Do you remember what is rancidity? Rancidity is the unpleasant odor, or taste of food. Why? Due to oxidation of lipids or fats in it. Okay? How does this oxidation take place? The hydrogen A1, that is hydrogen of lipids or fats are replaced by oxygen. Right, students? So your hydrogen of lipids are replaced by oxygen. Okay? So that is why it is giving you unpleasant odor or taste. Now in order to prevent that, what we have to do is we will put some more reactive gas there. Okay? Now the answer of this question is nitrogen. It is flushed with nitrogen. Nitrogen gas. Right, children? Now this nitrogen, in place of hydrogen, what will happen? In place of hydrogen of lipids, what will happen? This nitrogen will get oxidized and its gas will be escaped. Okay? So what is the answer of this question? Nitrogen. Oil and fat containing food items are flushed with nitrogen gas to prevent rancidity. Clear? Now moving to our next question. Write the chemical equation for the decomposition of silver bromide in the presence of sunlight. Now children, when decomposition takes place in the presence of light, what is it called? It is called as photodecomposition. Right? So this is called as photodecomposition. Now silver bromide, its formula is what? Silver and bromide ion, AgBr. Okay? Now this is being cleaved. So what will be the products formed, children? It would be, what will be the products formed? It would be silver solid plus Br2. Right? Now children, is our equation balanced? The products formed are silver and bromine. Right? Is our equation balanced? How many silver atoms are there on the LHS? It is 1, children. on the RHS is also 1. What about bromine? Bromine is 1 on the LHS and 2 on the RHS. Clear? How we will balance this? I have to put 2 in front of silver bromide. Don't change the chemical formula of the compound. Okay, children? So it should be 2 AgBr, that is silver bromide, and it is giving me what, children? It is giving me 2 silver atoms, right, plus Br2. Okay, now our equation is balanced, right? Now children, moving to our next question, it is 1 mole of Na2SO4 contains dash atoms of sodium, dash atoms of sulfur and dash atoms of oxygen, right? Now first tell me, what is 1 mole, right? So what is 1 mole, children? 1 mole is the amount of substance containing Avogadro number of particles. What is Avogadro number? 6.023 into 10 to the power 23 particles, right? Say I am saying 1 mole of electrons means what? There are 6.023 into 10 to the power 23 electrons. 1 mole of protons, it is also 6.023 into 10 to the power 23 protons. Likewise, here it's what, children? It is 1 mole of sodium sulfate, that is 6.023 into 10 to the power 23 atoms of sodium sulfate. Clear? So, this 1 mole of sodium sulfate contains how many atoms of sodium, children? What is written here is 2, right? So, what I can write here, it has 2 atoms of sodium, right? Dash atoms of sulfur. How many atoms of sulfur are here? 1. So I can write it here. It has got 1 atom of sulfur, right? So it should be 1 atom of sulfur. And dash atoms of oxygen. So how many atoms of oxygen are there? 4. What I can write here, children? It should be 4 atoms of oxygen. Is this question clear? Now to clarify your concept, let's solve another question of same type. 1 mole of HgNO3 whole twice. Hg is mercury, NO3 is nitrate, and here the valency of mercury is 2. So what will be its name? Mercuric nitrate. Clear? Contains dash atoms of mercury. So what is written here? 1. So I can write it has got 1 atom of mercury. Clear? Dash atoms of nitrogen. So how many atoms of nitrogen are here? It is 3 multiplied by 2. That is, no, nitrogen is 1 multiplied by 2. That is 2. So I will write 2. Clear? How many atoms of oxygen are there? 3 multiplied by 2. That is 6. So there are 6 atoms of oxygen. Clear, children? Now again it's 1 mole mercuric nitrate. What does this mean? That 1 mole mercuric nitrate has how many molecules of mercuric nitrate? 6.023 into 10 to the power 23 molecules of mercuric nitrate. Clear, children? Now let's move to our next question. Yeah. In corrosion, iron is oxidized by oxygen of air in the presence of moisture forming. So what is the product formed in this, children? It is hydrated iron oxide. Clear? So it is what, children? It is hydrated iron oxide. Clear? Or what is the formula of hydrated iron oxide? It is Fe2O3.XH2O. Right, children? So now taking up the next question, what type of reaction is this? Balance it. What is happening? C2H6 is what, children? It is ethane. It is an organic compound, right? Now this is burnt in oxygen and is giving what? Carbon dioxide and water. Now we need to balance it, right? Now how can we balance it, children? If I am writing, let's start with oxygen itself. How many oxygen are there? Now let's start with carbon. Carbon, if we'll start with carbon, it would be easy for us. Carbon is 2 here. What I can put here, children? I can put here 2. Right? So my equation will become C2H6 plus of O2, and it would be giving me what? It would be giving me 2CO2 plus of H2O. Right? How many hydrogen are here, children? It is 6. So I can make it 3. Right? Now let's check out for the number of oxygen atoms, children. It is 2 2s of 4 oxygen atom and it is 3. That is 4 plus 3 comes out to be 7. Clear, children? Now can there be, if I am putting it 7 here, how many oxygen it would be? It would be 14 oxygen, right? So in my next equation, let me put here C2H6 plus 7O2. Now children, in order to make this 14 oxygen, what I need to do is, if I'll make this 4CO2 and I'm making it 6H2O. Now check out, are there 14 oxygens? 8 oxygen and 12. 6H2O. There is O also. Right? So, how many oxygens are there with carbon dioxide? 8. With water? 6. So, there are 14 oxygen. But children, our C2H6 is to be balanced now. How many carbon are here? 4. So, what I can do on the LHS side is, I can put 2C2H6 plus 7O2 and it is giving you what, children? It is giving you 4CO2 plus 6H2O. Right? So now our equation is balanced. Right? So this was the last problem solving session of chemical reactions and equations, right? We have solved questions related to the balancing of equations, to the formation of chemical formula, or also on the types of reactions. So children, you practice more and more equations to learn balancing. It is a very, very important thing in chemistry.